You are designing an automated retraining strategy for a customer churn model hosted on Vertex AI. Although updated training data arrives every week, you need an approach that is cost-effective and operationally efficient. Which strategy best balances performance maintenance with resource conservation? Option A. Initiate retraining only upon detecting a substantial deviation in feature distributions between current production data and the historical training set. Option B. Trigger retraining whenever serving latency grows by 10% due to fluctuations in traffic volume.
Option C. Schedule retraining whenever model prediction accuracy on the most recent dataset decreases by at least 10%. Option D. Perform a model retraining cycle strictly once every week as soon as the fresh data becomes accessible.
When managing production machine learning models, deciding when to retrain is a balancing act. You want the model to stay accurate as real-world data evolves, but training cycles are expensive and time-consuming. You must consider what triggers a retrain. Should it be time-based, performance-based, or triggered by specific changes in the data environment itself?
In my view, the correct answer is option A. Retraining a model triggered by data drift is an industry-standard best practice. Data drift happens when the input data's statistical distribution shifts significantly compared to the training set, which usually degrades performance. Monitoring this allows you to retrain only when necessary, effectively balancing model accuracy with cost and compute resources. IT instructor explaining a certification exam question to students. Explain which answer is correct and why. Option B is incorrect because serving latency issues are usually related to infrastructure or serving resource constraints, rather than the model's predictive parameters. Option C is often less practical because ground truth labels required to measure accuracy are frequently delayed, whereas drift detection can be calculated using input features alone. Option D is an inefficient approach, as it consumes resources on a fixed schedule, even if the model's performance remains stable.